So, hi guys, we are Group 5 from Division O, and our topic is computer evolution and performance. So, hi, I am Varun Patil, roll number 25. So, the first generation, which was from 1942 to 1959, in which the main hardware component was vacuum tubes. The main characteristic was it was huge in size, highly expensive, and consumption of electricity was very high. The second generation lasted from 1959 to 1965. Transistors and magnetic tapes were the main hardware components. It was also expensive. The third generation was from 1965 to 1975. Integrated circuit was the main hardware component in it. It was faster, compact, and cheaper as fourth generations lasted from 1975 to 1988. VLSI microprocessor circuit was the main hardware component in it. It was faster, compact, and affordable. The fifth generation was from 1988 to the present. Main hardware component was ULSI microprocessor. Characteristics is parallel processing and AI technology. Some examples are listed on your screen. Thank you.
Designing for performance. So yeah, we know nowadays the cost of computer is decreasing and such that their performance and capacity increasing day by day. Here also pick up less than $1,000 that packs the volume of an IBM mainframe. The continued technology revolution has enabled the development of application of outstanding complexity and power. For example, desktop application that require the great power of today's microprocessor based system include, which is nothing but the first one is image processing, second is a speech recognition, third is a video conferencing, fourth multimedia authoring, fifth video and voice annotation of files, and last is simulation modeling.
Improvement in chip organization and architecture. The designer wrestled with the challenge of balancing the processor performance with that of the main memory and other computer components in order to increase the speed of the processor. There are three approaches achieving the increased processor speed. Increase the hardware speed of the processor. This increase is fundamentally due to shrinking the size of logic gate on the processor chip so that more gates can be packed together more tightly and to increasing the clock rate. With gates closer together, the propagation time for signal is significantly reduced, enabling a speeding up of the processor. An increase in clock rate means that individual operations are executed more rapidly. Make changes to the processor organization and architecture that increase the effective speed of the instruction execution. Typically, this involves the use of parallelism in one form or another.
The evolution of Intel x86 architecture. The current x86 offerings represent the result of decades design effort on complex instruction set computers. The x86 incorporates the sophisticated design principles once found only on mainframes and supercomputers and serves as an excellent example of CISC design, an alternative approach to processor design in the reduced instruction set computer risk. The ARM architecture is used in a wide variety of embedded systems and is one of the most powerful best design risk based system on the market. In terms of market share, Intel has ranked as the number one maker of microprocessors for non-embedded system for decades, a position it seems unlikely to yield. The evolution of its flagship microprocessor product serves as a good indicator of the evolution of computer technology in general.
The world's first microprocessor was 8080. This was an 8-bit machine. The 8080 was used in the first personal computer, the Altair. Then two 16-bit microprocessor was created, named as 8086 and 80286. Then 80386, which is Intel's first 32-bit microprocessor, was created. Then Intel created Pentium name microprocessor, in which they use superscalar techniques, which allows multiple instructions to execute in parallel. Pentium 2 is also the modern micro.
In evaluating processor hardware and setting requirements for new systems. Performance is one of the key parameters to consider, along with cost, size, security, reliability, and in some power consumption. It is difficult to make meaningful performance comparisons among different processors, even among processors in same family. Raw speed is far less important than how a processor performs when executing a given application. Unfortunately, application performance depends not just on raw speed of processor but on the instruction set, choice of implementation language, efficiency of the compiler, and skill of the programming done to implement the application.